Welcome to Penn State Dickinson Law's Profiles in Leadership series. My name is Beryl Lim. I serve as the H. Leddy Bontac Junior Chair and Associate Dean for Research and Innovation at the Law School. This series offers an unparalleled opportunity to glean insights from top leaders in their respective fields. In each episode, we invite these leaders to reflect on their journeys and share skills, core values, and qualities that make them the leaders they are today. We're very pleased to welcome Jenni Evans. Jenni is a professor of law, a professor of meteorology and atmospheric science, excuse me. She has forged a career by creatively merging research fields, forging interdisciplinary partnerships, and leading those partnerships in tackling complex science and society's biggest challenges. She's now retired. We'll talk about that too, but she was born in Melbourne, Australia. She earned both her undergraduate and doctoral degrees in applied mathematics at Monash University. She attended a weekend field trip to learn how calculus could be employed in understanding the atmosphere, and the experience opened her eyes to a career where she could use her passion in math in a practical and challenging way. During her doctoral studies at Monash University, she spent much of her time at the Bureau of Meteorology Research Center in Melbourne, Australia, and at the Naval Postgraduate School in Monterey, California. After receiving her doctorate, she joined the Commonwealth Scientific and Industrial Research Organization as a research scientist. She came to Penn State and has taken on many university-wide leadership roles, serving as acting director of both the Penn State Institutes for Energy and the Environment and the Earth and Environmental Systems Institute. In 2017, she was appointed the second director of Penn State's Institute for Computational and Data Sciences. She's also the centennial president of the American Meteorological Society, and is one of the only 5 women to have held the position of president of the American Meteorological Society in its century of existence. Welcome, Jenni.
Thanks, Daryl. I'm pleased to be here.
Well, let's start with your background. Talk to us about your student experiences at Monash.
Well, you covered a bunch of it in your introduction, so I can keep it brief. I loved maths, and physics kind of came along with maths. And so I didn't know what I wanted to do when I went to university, but I knew I didn't want to be a maths teacher. I thought that didn't suit my personality. So I just started working on maths and physics. And as you said, a camping trip where we looked at how to measure things in the atmosphere and in a lake really kind of tipped me into doing applied mathematics with a focus on the geophysical fluids so that I could look at weather, climate, the oceans, and so on as they interacted and as they impacted humans and other creatures. So that was really how I evolved into my meteorology degree, well, applied maths degree, but application to meteorology, how I eventually came to Penn State in my role initially as assistant professor in the Department of Meteorology and Atmospheric Sciences. I guess there were 2 or 3 major things I came away from Monash with. One, of course, was my practical qualification, which set me up well for all my future things. One was a love of the university itself, excuse me. And the last one was I met a professor, Bruce Morton, who became a lifetime mentor to me. And so each of those set me up really well for what I did next. So I think really that were the key things. I guess the other thing was you mentioned the Naval Postgraduate School. So I had the opportunity to spend 1.5 years in Northern California during my PhD. And it was split really. It was predominantly the Naval Postgraduate School, but I also spent a fair bit of time at the NASA Supercomputing Center in Moffett Field in Mountain View, California, in Silicon Valley. and then a little time at the Naval Research Lab, also in Monterey. And that again gave me experience, helped me develop future contacts, but it also let me know when I went back to Australia that just because you're overseas, it doesn't mean people forget you. You can go back and your friends are still there, and it really didn't seem like anything had changed. And over my around 3 decades at Penn State, whenever I go home, I still pick up where I left off with my friends and, of course, my family. And that meant a lot to me and really kind of gave me the confidence that I could travel overseas and explore my passions and still be able to go home.
You had mentioned in an earlier interview that Santa had something to do with you getting into meteorology. Can you talk a little bit about that?
Oh, that was funny. So I was a child when Tropical Cyclone Tracy made landfall in Darwin, which is if you look at Australia, it's in the middle on the north coast. And I was a little kid then, and it was Christmas. And it made a direct hit, and we knew that the city was in shambles. And my biggest worry was, would Santa Claus be able to find all the children whose houses had been blown away? And according to the Red Cross, he was a bit late, but he did find the children.
And that started a lifelong interest in hurricanes.
Well, it started a lifelong interest in meteorology, and it gave me a context for how hurricanes impact people in their daily lives. And that eventually led me to something beyond what I was doing at the university that addressed exactly that, how hurricanes impact people in their daily lives.
Why hurricanes, though, of all the different atmospheric phenomenon and meteorological disciplines you could focus on?
Partly because I found an advisor for my PhD who was an expert in the field, and we clicked. I was working for Professor Bruce Morton, my mentor, in a lab looking at fluid flow in a water tank in a lab that had no windows. I did learn how to develop photographs then as part of what I was doing, which was fun. And the work was fun, but I knew I couldn't spend my life inside a windowless laboratory. So I was looking around, I took some classes, I decided tropical meteorology was where my passion lay. And then I found an advisor, Greg Holland, who agreed to take me on for my PhD, and he was an expert in hurricanes. And after reading the literature and thinking back to the pivotal experience in my childhood, that was where I decided to go.
Can you talk about both of them for a moment and just point out some of the impressions, the experiences you had with them? You said they were great mentors. What was it about them that made them great mentors?
They were incredibly different people. Greg was almost bouncing around. He just sort of transitioned to one thing and another. One thing I shared with both of them is I think we're all intellectual magpies. We get a big new shiny idea and we follow it and we run with it. But sometimes you find another big shiny idea and you start off on that tangent as well. And you have a lot of balls to juggle in order to move all of those different things along. And one of the things I think that attracted me to Greg was that energy he brought to that kind of approach to the science. He was also in you mentioned the Bureau of Meteorology Research Center. That was where Greg, my PhD advisor, was. So he was an associate, what do we call it? Anyway, he was a guest faculty at Monash University, not a regular faculty member, but that still gave him the opportunity to be my PhD advisor. Bruce Morton, who was the one essentially that gave me the opportunity that opened the door to the meteorology, was a distinguished professor at Monash. And he was my Monash PhD advisor, as it turned out. And Bruce was still very energetic, loved his science, loved mentoring students and really helping other people succeed. And just a gentle man and a scholar, and just the most wonderful person. He, in a couple of times when I was feeling like I wasn't on the right path, he asked questions that let me conclude I was on the right path. He didn't try and tell me. And I found that to be a really strong example of how to help people through their careers.
Thanks. Do you see any differences in the way that Australia approaches its education of meteorology and how the US, if you like, Penn State approaches it? And if that differences, is it cultural, is it historical? What accounts do you think for those differences?
There's part that's purely historical, I think. Australian degrees follow the British model. So once we've left high school, our general education in the classroom is pretty much done with. I mean, you're expected to develop, but when I went to Monash, my undergraduate was a double major in applied maths and physics with a minor in pure mathematics. So those were the only classes I took. So I did a 4-year honours degree, and it was all those classes. So not having the gen ed is a big difference between the two. But it means that, and you don't take classes during a PhD either. So at each of those steps, it's assumed that the background you have is adequate to make that next step and focus that much more. So when you get to your PhD, it's purely research. And it's assumed that by having the honours at the high enough standard that you've already met the bar for the coursework. And really what that means is if you need a course, you teach yourself, and you find the right person to help mentor you through that material. And that also meant that once I got around to doing my PhD, I only spent 3.5 years in the doing of the work. But in between my undergrad and PhD, I worked in a mechanical engineering department, looking at the boundary layer of the atmosphere. And as I said, I worked for Bruce Morton in a fluids laboratory, looking at very idealized flow in a water tank and using that to think about the theory of how this thing called vorticity, which is a derived property, a way we think of the atmosphere in terms of how it operates. So you would look at the temperature and the winds, if you're thinking of a hurricane, and how they interact. And if they're in balance, the hurricane can maintain itself, or if they're in a somewhat different state, it will intensify. You can look at that all in terms of this thing we call vorticity. It's another way of combining information on the winds and temperature, and it lets us look in a very distilled way at what's happening in the atmosphere. And so Bruce's research was looking at how that grew, and using a water tank let us control things more so we could get to the very high level of detail on what was happening.
I see. And when you came to Penn State, did you see differences in the way that you approached the discipline coming from Australia compared to your colleagues?
Very much. The first class I was going to teach, I found out quickly that teaching an applied mathematics course in a meteorology program was a pathway to disaster, because we had been taught in a very theoretical way because it was a maths program, and students in meteorology, while they love maths and physics, they want the application. And so I had to learn, the first couple of years were me really trying to understand that and moving towards that. So that was certainly a difference, and that was a cultural difference in terms of the major, so meteorology versus mathematics. But it was also a difference in what do I want to say? In the approach to the classroom, I had to be much more entertaining here than I was familiar with. And on the other hand, in Australia, while we were more familiar in how we interacted with our faculty members, we were very clear where the line was between a faculty member and a student. Here, initially, I let my students call me by my first name, but that seemed to confuse the discipline, sort of the power structure, and made it harder in the classroom. So I went back to saying, call me Professor Evans, which felt very weird for someone straight out of their PhD, but it worked out much better overall. I guess having a young woman in front of the class in a very male-dominated field, even though our department was fantastic. It had some challenges about it, but they were soon sorted out.
How's that gender imbalance these days? Is it a lot better? Is it the same? Is it worse?
No, in fact, I think it's a lot better. And I was a bit befuddled during the period between coming to Penn State in 1992 and today. We had about 20% women for a number of years in the department, and then it really dropped off. And I thought, we've gone backwards and what's going on? And then we got back up to 20%, then we dropped off again. And now I think it's near 50%. It's still maybe 40, 60 or something, but things have really sort of settled in. It seems that women are confident now that they can do the work. And they're certainly of the quality to get into the field. I think that lack of confidence, that lack of seeing themselves, really made a difference to women choosing it and staying in the field. But we're past that.
Oh, go ahead.
Well, I'm optimistic that we're past that now, and I hope I'm not proved wrong.
So have people come up to you and said, Jenni, I'm so glad that you are in the field because as a woman, I can see women in the field succeeding and you're an inspiration for what I'd like to do.
It has happened, and as an Australian, I get very embarrassed when it does. It's really wonderful, and I've had experiences with women students that I've mentored over the years, and with some of the men too, where I went to a national conference. So when I was president, you mentioned, of the American Meteorological Society, I was lucky enough to host a conference for 5,500 people as the centennial celebration. And I had a number of times there where I ran into former students, even undergrad research students, who told me where they were in their careers. And it was so fun sharing their joy of what they're doing. It was something that's such a bonus in what we do.
Sure is. And looking back, you said you joined 1992, 2024. What would you say, in addition to some of these changes in the demographics, you've seen in the way that meteorology is taught at Penn State?
When I came, we were teaching in a very traditional way. So back then, we saw that our students would either go into forecasting with the National Weather Service, broadcasting, and that was then television and radio, and maybe doing newspapers, also newspapers, or go to university again and do a graduate degree. So those were the three options that we were teaching towards, and they were all very current weather based and with climate as a context. Now we have subdisciplines in atmospheric chemistry, in climate, in weather and climate risk, I'm trying to think, there's so many different things. So severe storms in terms of tropical meteorology, so many things, and there's always an awareness of how what we're doing is impactful in society. So the folks who are doing weather forecasting now there's very few jobs in the National Weather Service now. They've streamlined, they've modernized, and there's so much more that's at a very highly technical level that our students who go in the Weather Service are mainly doing development of new opportunities, new tools for forecasters to use. Some of them get your traditional job. Some of them more and more go into private industry, whether it's forecasting. I have a couple of former graduate students, one who's on Wall Street and one who's on Bond Street, who are forecasting for the futures market, so that the businesses they're involved with want to know what should they buy that's going to give them a profit in 3 months. And so they're trying to look at, seasonal climate prediction. I also have folks who are, of course, in the military, folks who are developing new things in private industry, a couple of department heads at other universities. Two of them are leading weather services in the Caribbean countries. It's really fun to see such a variety of things that former students are doing.
Speaking of the Caribbean, well, the day that we are speaking today, Hurricane Beryl is in the news. It's a Category 5 hurricane, according to the reports I've read this morning. Tell us a little bit about what goes through your head when you read news like that from the discipline that you are familiar with.
I think back to what I know about weather systems and think back to what am I, how can I understand what's happening? And of course, you worry about the people who are involved, but those two are not independent, right? So as I'm thinking about how I see the system evolving, I'm also thinking about what could be on the ground impact. And so with that in mind, I've done sort of 3 types of things in my own research career, and one that's in research application, if you like. So I've been interested in the life cycle of a hurricane from when it begins potentially off West Africa, or when it begins in the subtropics, so sort of in the region about North Carolina, Bermuda, that kind of latitude. And then those systems, well, not North Carolina, further east, not right off that coast. Systems develop there that look a bit like a tropical storm, but aren't quite the same. They're more shallow in the atmosphere. And if they move south, they can develop properly into a tropical storm and maybe even into a hurricane. And then they can have a big impact because they're close to land one way or another. Other developments right off the West African coast, one of my recent PhD students and now an assistant professor at Texas A&M, looked at how you can get African easterly waves developing and how what can we learn about how they evolve to tell us whether or not they might become a tropical storm in the far east of the Atlantic Ocean. Because storms like Hurricane Ivan form there and they travel very close to the equator for, the entire width of the Atlantic. And that warm water over that huge distance really gives them energy that maintains long into their career. Sorry, that's a clock. And so that's really important to me, is understanding that early evolution. At the other end of that, you get storms like Hurricane Ivan and like Hurricane Sandy in 2012 that did so much damage in New York, New England, New Jersey, that whole, mid-Atlantic and northeast part of the US, where it transitioned, we say transitioned, it changed its structure as it moved out of the tropics and became a very, very intense system. If you think about, grabbing a whole lot of high-octane fuel and taking it somewhere where it's anomalous, where it's unusual, then you become much more intense. So that's what this warm, moist tropical air in a cooler climate really let that storm grow in such a way that it was unusually strong, and a lot of damage comes out of those systems. So they're called extratropical transition, and that's been something I've been known for the last 25 plus years. Then, since those things have such an enormous impact on society, I've been interested in exactly that. What's the intersection with society? And so I've looked at that both in terms of helping to provide new tools for weather forecasting. So Bob Hart, who was one of my first PhD students, developed what we call the cyclone phase space. I won't go into detail, but what it does do is let it say, is the storm subtropical, tropical? Where is it in terms of the hurricane classifications, or is it extratropical? And having that information in a very compact form is what this phase space does. And it actually was operationalized in the National Hurricane Center, which makes me very proud and is also a point of pride for my students. So that was one way we help weather forecasting, and more recently looking at, so we used to in the field develop one forecast. So you take a computer model, you'd run it once and you'd say, this is what the computer model says. I see this other data. As a forecaster, I have this broader context and I develop a forecast, and there's one. Knowing that our computer models aren't perfect, our computers aren't perfect, our observations aren't perfect. Now what we do is we say we understand there are all these different uncertainties that go into even beginning that computer model forecast. So we do it 50 times or 100 times with very small differences in how we start the model off, and the butterfly effect takes over, right? And so we get a whole lot of different possibilities. But what we can say is from this situation in the atmosphere today, that we know all of the possible futures, or we hope we do. And from that, we use our judgment, our experience, and some observations that maybe didn't get into the computer model itself, whether it's because they didn't make it in time or they're wrong. They're, something like looking on the ground. And using those, we call ensembles of 100 weather forecasts. My group used some machine learning techniques to break them into subgroups that made sense. And then that gives the forecaster the opportunity to say, this subgroup is the one I think is going to happen. And within that subgroup, I see storms that look like this small subset, and I can use that to make my forecast. So that captures uncertainty, and it captures forecaster knowledge, and it wraps that all into an improved forecast.
So speaking of machine learning, I want to talk about ICDS, and that's where you and I had the chance to have our paths intersect.
Yep.
Talk about the intersection, if you will, between meteorology and your work at ICDS, and then talk about what you've done at ICDS.
Wow. So I think one of the reasons I was asked to apply for the position of permanent director of ICDS was the value I saw in what ICDS was doing, and the value I saw in interdisciplinarity as an approach to research and to having an impact. So all of the work I've done has involved supercomputing or very large scale computing, and more in using statistics to synthesize what I'm doing on the computer and take it to the next step towards practical applications. So in my own research, I had that intersection of meteorology with statistics and with large-scale computation, and thinking about it all the way to forecasts. And I have another aspect outside ICDS, maybe we'll cover later, that really ties into an interdisciplinary approach to science. But I'd had, as you mentioned, I'd been acting director of 2 environmental institutes on the way to ICDS, and having the perspective from those and seeing the difference you can make when you're administering a research organization is fantastic. So at ICDS, we have lawyers, loyal faculty members. We have faculty in medicine, in liberal arts, in health and human development. You name a college, we have education, agriculture, of course, science, of course, engineering, earth and mineral sciences, communications now. So that breadth we have of people doing research that leans heavily on computation or very large data sets or statistical machine learning AI approaches to synthesizing data in new ways is something that is absolutely essential to where we are in history of science and application of science today. And so having a part to play in that as ICDS director was just fantastic. I couldn't imagine when I stepped down as director, I'd been interim director for a year and director for 7 more, and it felt like a minute. It was just the most fun job to have, and I really enjoyed what I did there and the people I worked with and the people who we brought into the university, such as yourself. So that's very high level.
Thanks. I should mention for our listeners too, I had the privilege of being at Jenni's retirement party, and just listening to the people that came up one after the other to talk about their personal experiences with Jenni just shows that not only did she lead with her head and connect with her heart, she really made a difference to all these people, all in such different fields, from administrators to researchers to staff members at ICDS. You say it went over in a minute, but I think for them it was an experience of a lifetime.
Well, I hope at least 1 or 2 of them feel that way. Again, as an Australian, that was very challenging for me to stand there, but it was an incredible experience to hear people say what they did. It let me know that I had an impact. And it was a joy to have them all there, and just something I'd never thought of having in my life. I don't know. I'm very awkward at when people praise me. It's just a thing.
Actually, a couple of follow-up questions. One is it's actually a rare skill for somebody in one discipline to be able to reach out to so many different disciplines and to bring them together in a coherent vision. How did you manage that?
I think I get very excited about research, about new ideas in general. And I didn't have the ego to think I needed to understand everything. So I got excited about research, whether it was in new materials or new education approaches or how we treat data in an ethical way in terms of protocols and law and so on, or climate or galaxies or whatever, right? So there's so many different things our researchers were doing across all of those colleges, and I didn't need to understand it. I needed to be able to find a way for them to succeed and take these ideas to the next level. I also, interdisciplinarity, as you said, is key to what we do. So helping them find people in the different disciplines, or to, rather than do matchmaking, just give them the resources so they could create those teams and build new ideas around these intersections that were not traditional before, the institutes at Penn State, at least for our community, came into play. Because I really think our university level institutes, of which ICDS is one of 5 that are university wide really, and then 2 more that are heavily based in the medical school, are critical to Penn State becoming a leader in interdisciplinary research. Let me brag a bit about Penn State. So 3 or 4 years ago, or maybe slightly more, there was an article came out in the Journal of Higher Education. And they said, everyone's into this interdisciplinarity, everyone's into, cluster hires, but does it really make an impact, or are we really just sort of throwing a lot more money at something that we don't need to? And so they studied about 70 or 80 universities across the US, and they looked at the impact in terms of new majors, in terms of publications, in terms of grants, in terms of success of the people who were brought in on these cluster hires. And they really concluded that Penn State was the only one that demonstrated value for money on all of the metrics they could think about. And I firmly believe it's because of our institutes and because of the support that we've got from central, from Old Main, from our core administration, but also from our deans and our department heads, because ultimately the faculty members have a home department and a home college. And if those folks weren't creative and imaginative enough, the institutes couldn't succeed, because we succeed through the faculty. So Penn State has created a culture that's different to almost any other university in the US, and we're successful at creating new opportunities in new areas of science.
What do you think is the secret to that success?
Imagination, generosity, having emotional intelligence. That means you are motivated to understand enough of another person's field that you can ask the right questions and find points of intersection, but not arrogance to think you know what they do at a deep level.
And why Penn State and not elsewhere?
Because early on we had a few people with imagination and vision who were able to sell that vision to others.
And as you've passed the baton to the next generation of leadership at ICDS, what are some of the 2 or 3 things you like to see ICDS be able to accomplish if you like carrying on your legacy?
Well, I think that we have continued to chart new paths. So there are a few things that we were beginning in the research that I think are going to grow. I mean, we've spent a lot of time developing artificial intelligence as a theme across research, across the entire university. While it's of the moment, and it might seem a little trite to say that area of research, it's a fact that it is permeating society so much that is key. Another thing that we're thinking about, which is kind of an outcome of AI, so artificial intelligence, if you're using it with big data, is an enormous energy sink. You require incredibly large computers and incredibly long simulations in order to really use that as a tool. And what does that do? That chews up an enormous amount of electricity. And, if the electricity is generated using fossil fuels, that causes a whole lot more emissions into the atmosphere and may feed back into weather systems and disasters down the road. So you can see that you go from a simple computer chip and a simple piece of research or application to the climate. So that's the level of interdisciplinarity we're thinking about now, right? And so there are people at Penn State who are thinking about, how do we do AI more efficiently? Is it always the best use? Are there other things, other tools we could use that in fact give at least as good insights as if we do it via AI, and there are other ways that could happen? And if that is the answer, how do we optimize how the computer operates? So when you get onto your laptop, you get folders up and you manipulate things. Can we do that in a more energy efficient way? And then sort of how can we connect to the most energy efficient or environmentally favorable power systems? And how can we do life cycle use of computer parts? All right, so how can we not just generate enormous amounts of electronic junk that goes to landfills? So all of these are different things that are intertwined in what do we want our goal to be in the computation? How do we choose the best method? How do we choose the right computer architectures? How do we reuse materials so that that computer architecture evolution isn't creating an ever-evolving set of junk? And how do we do all of that in an environmentally aware energy space? So that's a completely new vision that ties in so many aspects of what we do across the university.
Thanks. Tell us about your interactions with the unit heads, the deans, the colleges. And when you talk about cluster highs, it almost has to be like a marriage. Both sides need to want this to happen. And both sides, I suppose, have to sell and believe in the value proposition of it. Was it an easy sell?
Initially, it wasn't. I mean, when I first began, the founding director, Padma Raghavan, had multiple roles, and the institute was in its very formative stages. And so when I came in, I found that one of the things I needed to do was to expand awareness of ICDS and what our mission and vision were. And at the time, the provost and the vice president for research were incredibly supportive and really gave me some impetus and some resources to do that. And so once we got the attention, I guess, of the deans and the department heads, we were able to then start creating opportunities for partnerships. So one of the things we did was to get a group of faculty together in a faculty council and to say, where are the few key areas of research coming up over the next decade? Which of those is Penn State already able to lead in? So we either are leaders or we have people who, with a little resource, will grow into national and international leaders. And where with a little more investment could Penn State be in that leadership space? And so that's how we trimmed down what we wanted to support in terms of research, but in an interdisciplinary way. Then we asked department heads and deans to provide a description of the kind of faculty member that they could see in their department whose research would support these goals. And that was really a way, again, to expand the awareness of the departments and colleges into what we're doing. And we got, each time we did that, we got about 15 applications from across the university. Each time we were able to take 4, one of them 5 times, and recruit faculty who were at that intersection. And because we did it that way, we already had the buy-in from the department and from the college and support for their faculty being engaged with ICDS, as well as all of the other intellectual spaces they operated in.
Thanks. Now, the other space that you're known for at Penn State is the relationship with Monash, which really is a singular effort and credit to you in terms of the depth and breadth of that relationship. In fact, Monash recognized your efforts and named you a Monash Fellow. Can you tell us a bit about those collaborations with Monash and what being a Monash Fellow means to you?
Yeah. Well, the easy one, being a Monash Fellow, was just such a joy. As I said, I left Monash with a love for the university, and the fact that they saw what I'd been doing as of value was wonderful to me. The partnership came about from, well, actually from both. I found out later that the Monash president at the time, Margaret, had come to Penn State and was keen for Monash and Penn State to partner. But I didn't know that when I began working the other way. So our then provost, Nick Jones, and vice provost for global engagement, Michael Adewumi, were keen to have a very small number of very deep partnerships with Penn State, with other universities, and have those partnerships geographically dispersed. And so we already had partnerships with China and with the UK and with one other country, and I can't recall. And they were keen to get one in the Antipodes. And so we took essentially a fact-finding tour and visited Monash University, Melbourne University, and University of Auckland to see if there was any natural fit. And by a natural fit, we meant a university that had a vibrant intellectual ecosystem and that had a research culture that was a good fit. And so each of them was intellectually vibrant, but Monash had the strongest bent and support for interdisciplinarity and for a global vision. And when you worked with the folks at Monash, they had a similar personal approach to things. So essentially, our faculty and their faculty were very excellent in their field, but relatively relaxed in how they interacted with other folks and had that combination of maybe a little bit of arrogance, but belief in their own capabilities, but also the humility to work across other fields that I think is critical.
And do you see Australia and the US being able to work more closely together, building on these types of relationships as well?
I do. In very recent times, the Commonwealth Scientific and Industrial Research Organisation in Australia, otherwise known as CSIRO or CSIRO, has partnered with the National Science Foundation in the US to offer joint funding for research areas that are critical to both units, to both countries. And so when you're seeing at the highest government levels that they're willing to invest in these two countries partnering together, I think that says that we can expect to see growth in what's coming out of those partnerships and expanding in different areas. And I think it makes a lot of sense in terms of the research excellence and the people.
Thanks. We're down to the last few questions now. So this goes to advice, especially to our younger listeners. First question, what advice would you have given to your younger self?
Try and be a little less of an intellectual magpie. You know, when you have so many balls in the, it's so much fun, but it really can be stressful because you have to deliver. And delivering when you've got such a diversity of things can send you chasing your tail a bit. So don't stop, but try and understand when you've put enough of a load on yourself. I think that's a critical one. Believing that you make a difference when you're doing it, I think is another one. You know, when you're so busy with what you're doing, you don't put your head up and see if you've made the difference you wanted, perhaps as often enough to sort of calibrate. So that's another one. Relax. So I think they're the main ones. I feel like I've contributed personally. I've helped other people, which was critical to what I wanted to do. I do feel like I made an impact, but at the time I wasn't sure I did. So, you know, give yourself a bit more credit, perhaps.
And talking about relax, what does relaxing look like to you? Do you think you've been able to keep a good work-life balance?
I wouldn't ask my husband. I wasn't very good at substituting responsibilities. So when I was directing ICDS, I became the centennial president of the American Meteorological Society. And so I just added that to what I was doing. I didn't substitute that. And I still had a couple of PhD students working with me, so I had to honor that as well. And so really, for that period of time, my husband became sort of co-pilot, and he he enabled me to do all of those things. And I think he hung in there for quite a few years in that role. And, you know, retirement's a chance for me to give back, if you like.
And what does retirement look like and giving back?
Well, the first week I was retired, I did a consulting job.
That doesn't sound like retirement to me.
Well, the thing is, I get to choose them. And this is one job I've been doing for 20 years now, working for the Florida state government, looking at how computer risk models, proprietary models, predict the risk of hurricane damage in Florida. And that's important because those computer models are used to help set insurance rates for Florida residents. And so that's where really my research, you know, it's where the rubber meets the road. It's where what I do impacts individual lives, because if they can't afford insurance, then they can't have a mortgage. And if the insurance is too low, the companies go out of business if there's a major event. So it's a real balancing act. And that is an interdisciplinary team of me, computer scientist, statistician, structural engineer, hydrologist, and actuary. So I live interdisciplinarity there. So I will be doing some of that. We're traveling. We're going to a wedding in Portugal. We're going to see my family in Australia. We're traveling around the US. And then we're trying to sleep to catch up on, what was it, 30 years of lack of sleep.
It sounds like a full agenda and a rich one. So on behalf of our listeners, I want to wish you a very happy retirement and thank you so much, Jenni, both for what you've done all over all these years for Penn State, for ICDS, for the relationship between the US and Australia, Monash and Penn State. And me personally, it's been such a privilege to get to know you through our interactions at ICDS and now in this conversation. So all the best, and we look forward to hearing more from you in the years to come.
Well, thank you, Daryl. This has been fun, giving me an opportunity to reflect, and I've enjoyed working with you. And I won't disappear, but I'll certainly be happy to see how the others are doing leading research now that I am much less involved. All right.
Thank
Thanks so
you.
much.
Thank you.
Bye-bye.